Hi folks, welcome back to Nibbles and Bites. I'm finally back from VCF Southwest. It was a blast and I got a little bit of footage, so we'll have some of that in this video in a little bit. I'm actually trying to repair my H11A. Unfortunately, it decided that the serial port was going to give up the ghost. Yeah, at the same time, while I was there, someone came and approached me and then offered to give me this paper tape punch here. So with any luck, I'm going to do a series of videos on this entire setup, and we're going to go through from aligning the discs on this machine to make sure that both drives can read each other's discs. We're going to fix the serial card on this guy, and then we're also going to see about fixing the parallel card and also this paper tape punch, along with this really crazy punching die. But for this video, let's focus on VCF Southwest. Now at VCF Southwest, I did two things. The first one was I was part of the YouTube streamers panel headed up by Bill Hurd, and I mentioned that in the previous video. We've got some footage from that. My dad managed to get some footage of wandering around and looking at all the exhibits. Unfortunately, I didn't get a chance to interview anybody because I was manning my table too frequently. And aside from that, I also did 3 shows out on the show floor about writing programs in QuickBasic on a PS2 Model 77, which I'll also have the footage of, and I actually managed to grab that. So those of you who couldn't make it to VCF Southwest, this video's for you. So with that being said, let's switch over to the footage and take a look.
VCF Southwest, we're glad you're here. Thank you. Thank you for coming. On our far right, way down there, is Taylor and Amy from the Taylor and Amy Show. Give a big round of applause. Next to them is David Beam of the IBM Museum. And even though it's IBM, we can applaud. Who's next? Next is Dr. Mark Verdell, Curious Mark.
Everything's all synced up. Hello, everybody.
Hello!
Hello! Are you ready to heckle and jeer?
Oh, I got with it.
Hell yes, let's get on with it. Okay. All right. So, you got your vintage computer. It's an IBM. It's running MS-DOS version 622. What do you do with it?
QuickBasic.
What else do you do with it? You play games.
Oh, nice.
Well, let's make a game. Or let's make something. Let's do something fun. So we start QBasic. And you run BASIC, right? It's MS-DOS QBasic. Well, what do you do with QBasic? Well, you do what everybody does, right? You do 10, print, hello world, 20, go to 10, right? All right, you got hello world. You can spice it up a little bit. You could do a semicolon, and then you get a lot of hello worlds. Woohoo! You know, heck, you can even make it a little more fun. You can say farts like LGR does. But let's be a little more creative. This is MS-DOS QBasic, right? We have colors. Multicolored farts. But that's not enough. We got to make it even more fun. Let's make those farts big. Now this might take a little bit of time on the projector. Multicolored big farts. That's great. But wait a minute, we can do even more. We're in mode 13. We have 256 colors. I know. Ah, wait, we gotta fix that. Now we have all 256 colors of farts. That's great.
It looks great.
But we can do more. This is QBasic. This isn't like the BASIC on the old Commodores. This isn't like the BASIC of our forebears where we had to use weird if constructs. We are using MS-DOS QBasic. That means we don't need line numbers. We can use things that are not keywords as labels and still do the same thing. But wait, we can go further. There's more. We could do while one, when. And now we're still looping. But this is getting a little too smelly in here. Let's make this some more fun, right? Let's draw some lines. Let's draw some lines. So let's do line from, let's do it this way, actually. Let's make some arrays. We'll do dim x, and actually we're going to do this with a counter and a constant. So const number of vectors. And we're going to say 2 for now. And then we're going to dim x at num vectors. And dim y num vectors. We're going to call these integers. Okay? Then we've got to initialize these because otherwise they're all zeros. So we do for I is equal to 1, 2 num vectors. Next I, and then we say x of I is equal to R&D times, what's our screen width? Close. What's our screen width?
320.
320. But we can't do 320. We got to do 319. Because if you do 320, you're off the edge of the screen. Y of I equals R&D. How many pixels tall are we? 200. But we can't do 200, we gotta do 199. Okay, so now we've got our X and Y's. No worries, no worries. Okay, so we've got to iterate through these vectors, because vectors are points on a screen somewhere, right? We want to draw a line between those 2 points. So we say for I equals 1, 2 num vectors, step 2. So, step 2 means that we add the number of steps to the counter each time we go through the loop. So instead of going 1, 2, 3, 4, 5, we're doing 1, 3, 5, 9, like that. So that means we can do this. We do x of I, y of I for the first point, right? And then we say x of I plus 1, because we're skipping over that extra one. With y of I plus 1. And then we'll do our random color. So we'll say RND times 255. And we actually don't need this anymore because that doesn't matter. And now, when we run our program, we got a multicolored line. Well, that's kind of cool. Let's do some more lines. And I don't mean lines of crack. More lines. So we're going to say, let's do 20 lines. All right, that's great. They're multicolored. They're like shining, doing the shimmering bit here. That's kind of cool. But we can do more. This is QBasic. We have the power. So we'll do some more. Let's actually make these things move. So, in this case, we're going to say dx is num vectors as integer, and then dim dy of num vectors as integer. And then we have to initialize them. So we say dx of I in the initialization routine. We say is, for now, we're going to say it's -1. dy of I is equal to -1. Now, if we run it as is, nothing really changes. But we've got these extra bits. These are our deltas. These will count us across the screen. And because they're -1, when we hit the border, we can reverse the sign and bounce it off the wall. So, we're drawing them. We need to update the x and y coordinates. So we do it again. We say for I is equal to 1, 2, num vectors, next I. And here we say x of I is equal to x of I plus dx of I. And y of I is equal to y of I plus dy of I. If we run it, now we've got them moving off to the nowhere. We got to do the bit where we actually flip the bit. So we got to go in there. We come back, and now we got to do a bounds check. We say if x of I is less than 1, or x of I is greater than 319, then, 18, sorry. Right? And then we say dx of I is equal to negative dx of I. And we do another one. If y of I is less than 1, or y of I is less than 199, or sorry, greater than 199. 198, yeah, you're right. Then dy of I equals minus dy of I, and if, right? Okay, so now we're going to be incrementing our x and y's based upon the dx and dy values. And if we go too far that way, then we bounce. If we go too far this way, we bounce. And likewise for the x side, y side. And now they're bouncing. So we've got moving lines. This is great. They're multicolored. It's awesome. But they're drawing on each other. This is not really great. You can't really see the lines. So how do we fix that? Well, yeah, we could clear the screen. Let's give it a shot. So we'll use a command called CLS if my screen ever comes back. There we go. And so every frame, we'll do a CLS. But that's kind of slow. And it's flickery. It's not super great. They're moving, though. And you may not see, but the top half of the screen is starting to get a little choppy. Like sometimes we get lines there, sometimes we don't. It's a little easier to see on the LCD, but we'll get to that. So instead of clearing the whole screen, because it takes so long, we want to do the minimum amount of work possible. Bingo!
Huzzah!
Yes! So we draw over our previous lines before we draw the new lines. So to do that, we do this. Dim OX of num vectors as integer. Dim OY of num vectors as integer. Come over here. We don't need to initialize them. They start at 0. And then in here, we do this. Line of OYI, and actually instead of writing it whole, I'm just going to copy and paste it, because this is QBasic. We have the power.
It's clumsy, but it's there.
Yeah, this is really clumsy. So there, like that, and then we change these to OY and OX. And instead of doing R&D 255, we say 0, because our background color is black. Okay, and then down in the update here, before we change our x and y, we want to save them. So we put them into OX of I is equal to x of I. We do the same thing for y. And we get rid of the CLS. Thank you very much. Okay, so now we got moving lines, and they're stable, and they're going all over the screen. This is great. Let's do more lines. No crack. Save it for later. Let's do 40. Awesome. We got so many lines on the screen. It's running a little slow. It's kind of choppy. Actually, I'm surprised it's doing pretty good this time. But for the sake of argument, this is choppy. It's slow. It's not super great. Part of this is because we're in QBasic. QBasic is DOS QBasic. This is like the minimum version of QBasic that Microsoft could make. So let's switch the gears a little bit. Let's save this file. And let's use the full power of QBasic. We're going to switch over into using something called QBasic Extended. This is Microsoft's last QuickBasic version they ever made before they switched over to doing Visual Basic. This is called the Microsoft QuickBasic Professional Development Edition version 7.1, otherwise known as QBX. And we're going to do that on power next.
We got the power.
We have the power, and it runs double speed. We can do double the lines. But here's the trick. Again, you can't really see it on the projector, but up at the top we're getting this weird effect where lines start disappearing. There's a trick here that you're not seeing. We're drawing so slow that we're updating our RAM first, and then the video card comes by and it tries to draw it to the screen. Now, on an LCD screen, that's almost instant. But on one of these, which is what this machine was supposed to have, it draws by taking a beam of electrons, and it draws them across the screen from top to left, or from top left to top right. And then when it gets to the right, it has nowhere else to go. So it has to turn off the beam, and then using a big electromagnet in the back, it pushes the electron beam over to the left, and then it turns it on, draws the next line. And we call this the raster. It keeps happening over and over again. So when we go from right to left instead of left to right, we call that a horizontal retrace. And there's a delay there. We can make a screen change there, but it's really, really short. By the time we get to the bottom right, we have a situation now where we have to push that beam using the electromagnets all the way to the upper left. And that's the longest time while that beam is turned off. If we make our video RAM changes in that period, then the next time we come to go draw that screen, it'll be nice and clean. We won't have any torn pixels. We won't have any torn lines. It'll look really beautiful. So we need to do this. We need to wait for what's called the vertical retrace. Now, there's a way to do it in BASIC that I just learned yesterday, but we're not going to do it that way because I'm crazy. And we have the power, the full power of the professional development system. We don't just need BASIC. We need assembler. So in this file, we have an assembler program, and this provides us a new basic keyword called vsync. Now this is weird, but it's cool, because it allows us to do something much faster than what BASIC can do. In this case, we're reading from the VGA's retrace register, and we're trying to figure out when our electron beam is in that lower right corner. When it's there, we return back to BASIC. So, to make this actually be usable by QuickBasic, we have to say massim on vga.asm, and that will give us vga.obj. And from the obj file, this is not usable by the computer. We have to do one more step. We have to use this tool called makeQLB. And that calls into link and lib to give us this file called a QLB, or a quick library. This is a library that's prepared to be loaded into a BASIC editor. So if I do makeQLB VGA, that will call the linker and then the library. And now I have this file called vga.qlb. And if I run qbx/l vga.qlb, initially it doesn't look like anything changed. But if I do this, vsync, and declare sub vsync, like that, and run it, it works. It's not a syntax error. We have successfully extended the basic language with a machine language program. So, what do we do with power? We abuse it. I mean, we actually use it. We'll put it in vsync right here. Ah, right, I gotta define it. Declare sub vsync. And now we have buttery smooth lines moving all over the screen whenever it syncs. There we go. And now we're syncing to each frame. There's some other artifacts here. We're also dealing with slow basic routines because we're actually drawing too much. And so we end up with some black lines. So if we reduce the number of lines, it'll get rid of that tearing. Back to 20. It looks a lot better now. So the last thing I wanted to do is I want to make sure that this looks like an actual Mystify screensaver. That means we need a polyline. We need to draw this thing all over the screen, right? Instead of a bunch of line segments. So to do that, we do one more thing. We get rid of the step 2. And then we say num vectors minus 1. And we say j is equal to I plus 1 mod num vectors. Did we use a minus 1 there? I can't remember. Yeah, I didn't think so. Okay, so that will actually allow us to use a secondary counter and then wrap it around. Yes, that's right, plus 1. Sorry. You are correct. Well, no, I'm doing that with the I plus 1 there.
Well, yeah, but num vectors is equal to the valid maximum
right.
Index. So you want to have 1 plus that for your argument for mod.
Yes, I believe so. Yeah, you're correct. Okay, yeah. So then, for our second vector, instead of doing this...
Consider, though, that there will be a slot 0 that you haven't initialized.
That is true.
So you might want to actually put parentheses on everything but the plus 1, and then you're good to go.
Yeah, I think you're right. So, oh, God.
Also,
Do it like that. Oh, like that? Yeah.
I would be at 0 base personally.
I know. I would do option index 0, but everybody's used to using 1, so... Really? I thought it started with 1. Yeah, I'll have to look at that. Anyway, we replaced the I plus 1 with j. Okay, and now we are iterating through each individual vector and continuously drawing the line. So now, here we go. We've got a polyline. We have now recreated Mystify in BASIC. There's a few other things you can do with this version of BASIC. You can do subroutines. So the interesting bit about this is that I did this earlier. We can actually make our program even simpler. We can do things like this. Take this initialization routine, right? And we can do new sub. And we'll call it initialize vectors. And we can do this in a subprogram of the whole program, making our code even more structured and even easier to follow. Of course, we have to do this to make that available to the subs. And it works exactly the same way, but now we have a much cleaner main program. We can do that with everything. But we can take it one step further. I'm not going to actually go through this because it'll take even more time. But instead of doing these gigantic arrays like this, we can do custom types.
Good afternoon, VCF Southwest. Just a couple of final announcements. The exhibition hall will be closing today at 3 p.m. Also at 2:30 p.m. is the cutoff for the UPS.
So then we can use that in the same place by generating an array like this. We say dim shared vectors, num vectors as vector. And now we can pass that around between our subs and do all kinds of stuff. So that's it. And that just about wrapped up VCF Southwest for me. After my demonstration, we had to scramble to take down everything and get it all out into the truck. Unfortunately, it was because of a misunderstanding of the timing of when the show was actually closing to the public and when exhibitors could get out. But regardless of that, I would like to give huge shout outs and accolades to the VCF Southwest organizing team. You guys are amazing. You were working so hard, almost to the point of exhaustion. And my heart goes out to you for some of you who really did push it to the limit. Thank you so much for making that whole show go off without a hitch. It was amazing, and I hope to be part of it again next year. Also, I'd like to give thanks to John Allison for approaching me during the show to talk to me about his paper tape punch. This is a very rare beast, and it's almost one of the hardest things to find for an H11A. I hope to get this working with the H11A in time for VCF Midwest. So look forward to the next few videos on this. Also, I'd like to give a huge shout out to my patrons. You guys are amazingly patient, and thank you so much for bearing with me through all these crazy times. I know it's been a little bit slower than I would hope, and it's kind of meandered a little bit in terms of the content. But hopefully we can get back towards more what we were aiming for with the original channel, and maybe broaden our horizons a little bit. Thanks for watching, and I'll see you in the next video.